Okay, are you able to hear me?
Supposed to respond.
Okay. All right, so I'm going to assume that you can hear me. Okay, I'm just going to go ahead and start going. I don't know if anybody else is going to make it today or not, um but here we go. So at the same time, I'm also going to assume that you can see my screen, that you can see my Word document here just fine. If you have questions, you can unmute yourself, or if you want to use the chat box instead, you can do that. Either one is fine. All right, we are going to be looking at 2.3. It's a very short section. It kind of gets us prepped for being able to do things with perfect, thank you. So it kind of gets us prepped for being able to look specifically at equations of lines and graphing. And so we kind of start with the basics of what we're doing. And so here we're going to start with being able to just simply determine if an equation is linear or not. And we're going to use a new form of equation called standard form. So when we look, standard form right here is this equation where we have ax plus or minus your by is equal to the c term. So we have a, b, and c are going to be the numbers or the values. X and Y are your only two variables. Now in this standard form, we have a couple of rules. The first one is right here, that your AX term, so this front term here, must be positive. So if it's negative, you need to take care of that negative by moving it to the other side. And then the second rule is the big one. This big one here says absolutely no fractions. So A, B, and C must be whole numbers in order for your standard form to work. Okay. So the first thing that you are going to be asked, or the first types of problems you're going to see, are going to be identifying if a given equation is in fact linear, and then if it is linear, rewriting that equation so that you are in standard form, okay? So if we look at this first one, notice I have this big crazy equation. And the first thing you need to remember is you never want to assume that an equation is or is not linear. You have to work it out and solve it down before you can make your claim on whether something is linear or whether it is not linear. So here, the first thing I have to do is take this 4 out in front and distribute it through my parentheses in order to change my equation. So this is going to become 9x, and then we're going to have plus 4y minus the 4x is still equal to 3. With this, we have to combine our like terms. So remember, when we're talking about like terms, we're talking about terms that are the same. So this 9x and this 4x here are those like term equations, and so those we would put together and combine. 9 minus 4 gives you a 5x plus the 4y is equal to 3. Because down here, there's absolutely nothing left that we can do. This equation is as is. I have nothing more that I can combine or simplify or put together. This is when you would ask yourself, is this linear or is it not? And if it is, can I fit it into standard form? If you remember, again, standard form is this one right here, the ax plus by equals c. And if you look at the form we have, it's in that exact same form, okay? So here what we actually have is ax plus by equals c. So we would select and state that this one is in fact linear, and then in Hawks you will be given a place where it then wants you to enter in your standard form. So that's exactly what you would type. You would type 5x plus the 4y is equal to 3. And that is going to give you everything you need to answer this particular question. Okay, so there's not a lot of work that you have to do on these. It's just simply about combining your like terms and putting it all the way down as far as you can. And then asking yourself, does this fit my definitions for linear? Meaning my x term has a power of 1. And can I then rewrite it into that standard form equation by putting my x and y on the left side and my constant to the right? Okay. So do you have any questions on the general idea of what you're doing?
Can you hear me?
Yes, I can.
Yes, ma'am. I have no questions.
Okay, cool. Then I'll move on to the next one. So again, this is the exact same question. We are asked to determine, is this linear? And if so, can I put it in standard form? And this one is a great example of do not ever assume before you actually work it out. This particular question, a lot of students in the past have gotten wrong, and the reason we got it wrong is because of this term right here out in front. Because we see that little square piece, we automatically assume, oh, this is a quadratic, so it's not linear, and then you move on to the next question. The reason why that's incomplete or that's wrong is because this back term here also has this little square piece. And so you have to make sure that we know whenever you have a binomial squared, we have to use one rule and one rule only, which is you have to FOIL your square term. Okay, so here, the first thing that we have to do is we have to take the fact that we have this x squared out in front, and we have to subtract, but we have to FOIL these middle two terms together. So remember, when you FOIL, you can either do it as is, but essentially it is saying you have to take your term and you're multiplying it by itself the once. So here you've got first, then outer, then inner, then last. And so that's exactly what we would do here. So we're going to have that front term is x squared, still comes down. Then I'm going to open a parentheses. I have x times x, which is x squared. I then have negative x minus another x plus 1 times 1, which is 1, is equal to my y term. Again, combine my terms. I have my x squared out in front. I've got my subtraction. This is still x squared on the inside. Negative x minus x is a minus 2x. And then plus 1 still equals my y. Now, the last thing I have to pay attention to is this piece right here, in the fact that this needs to distribute on through. And so we need to make sure we do that so we can combine our terms. And if you look at what happens with your squares in this case, I have an x squared, and I'm now subtracting an x squared plus the 2x. It's now minus 1 is still equal to y. So if you look at these two front terms, now when we look at them, they go away. That goes to 0. So therefore, we are simply left with 2x minus 1 equals y. And so therefore, is this linear? Well, if I look at my x term, it now has a power of just 1. I still have a y term, and I've got my constant term, which means, yes, this one would fall under my linear. And I'd have to rewrite it into standard form. So here we have to rearrange into your proper form, ax plus the by equals c. So to do that simply says I have to take my y and move it over onto my x side, and I have to take my 1 and move it to the other side, giving me a standard form of 2x minus y is equal to 1. Okay, so any questions on that one?
No, ma'am.
Perfect. Now, if we look at this third one, this one, there's really no work that we have to do because we've got this crazy term right here in the center, this little xy term. And because this is x times y, there is nothing I'm ever going to be able to do that would allow me to split that term and give me something linear. If I were to take this and say divide the x out of it, I would create a fraction on this right-hand side, and I can't have fractions as part of my rule for standard form. And same if I were to try and divide this y out, I would create a fraction on my 3. And so therefore, this one is just purely not linear because there's nothing that I'm going to be able to do that would give me standard form in its proper form. Okay. If we look at this next one, what we have out in front here is just simply a plus sign, and we know whenever we distribute that plus through parentheses, everything stays the same. So this would remain as negative 4x plus my y plus my x is equal to 9. And then just like before, we would have to take my two terms, so this 4x here and this positive x, these are the two that would be combined together as our like terms. So negative 4 plus 1 gives me a negative 3x plus my y is equal to 9. And so when I first look at this problem, notice I have an ax squared, I have a y term, I have my c term. All of my variables have a power of 1, so this one is linear. But we have a little problem right here. Right out in front, we've got this negative, and our rule again says that you can have your ax term must be positive. Therefore, what we have to do is we essentially have to flip the signs of the entire equation in order to remove this negative. So there's a couple ways that you could go about doing it. You could just simply, you could multiply by -1, or you could just simply rewrite the equation on opposite sides of the equal sign and flip all signs when you do so. Either one, I mean, is going to kind of get you the exact same thing. Essentially, what we are getting at is that you have to have 3x minus the y equals -9 as your result. So however you choose to approach it, you should end up in the same place as long as you remember you have to do it to every single term you have. So every term would have to flip in order to preserve what your equation actually is, or what you did was you changed your problem. So just be careful when your a term is negative at how you approach removing that. Okay?
Okay.
All right, so here's another one where again, we've got this pesky little square that we need to pay attention to. And so we want to make sure that we take that into account, which means we have to FOIL this front term together to get started to see what happens with these square terms. Can they be combined or not? So here you would have 9 times 9, which is 81. Then we're going to have plus a 9y plus a 9y plus the y squared. Then we have minus the y squared. And this is going to equal negative 7x plus the 7. Okay. So again, we have to combine your terms together. So we've got these plus 9y's that I can put together, and I have these y squareds that I can put together. So I need to make sure I combine both of those first before I do anything with the other side of my equation. So here this becomes an 81 plus an 18y. And then this is going to equal the negative 7x plus the 7. Y squared minus y squared goes away. Therefore, since the square disappeared out of the problem, this became a linear problem. Now, the only other thing that's left is the fact that I have constants on both sides of my equation, and right now this x term here is negative. So I have to take care of that before I move anything, which means I'm going to want to take this 7x and pull it over to the y side. So I'm going to move this 81 over to its other side. So this means you're going to end up with a positive 7x plus that 18y, and then 7 minus 81 gives you a negative 74 as a result. Okay, so that is what we're getting into when we talk about determining if something is linear or not. It just boils down to, when you get to the very bottom, do all of your variables still hold a power of just 1? And then can you rewrite it into its standard form, preserving the rules that kind of go with them, okay?
Okay.
So not so bad, as long as you remember that you just have to start by doing the math. Don't start by assuming you know the outcome. Okay. Now, the other piece that this particular section holds is your beginning of graphing. And so we graph kind of down at the basic level, which is just simply using your x and y intercepts to do so. And so you're going to be given equations that are kind of all scrambled up. So the first thing you're always going to have to do is you're going to have to rewrite or rework that equation to get it to where you want it to go. But you also have to remember what your definitions of your intercept are. So your x-intercept itself has a formula, and that formula here says that you would have x comma 0. And what this essentially means is it means that you are going to plug 0 in for y, and you are going to solve for the x term. Okay? Now, we also have a formula for your y-intercept, which says 0 comma y. And this is going to hold a similar definition in that you are going to plug a 0 in for x, and you are then going to solve for y. Okay, and so that's what your y-intercept is. They will always be of these two forms. So this right here is your x form, and this right here is your y form. Now, that also means that you have to put your answers in their form, okay? So when you are working it, the biggest thing to remember is that if you state, say, y equals 3, this is no credit. And the reason for that is because y equals 3 is not an actual intercept. Makes sense? So instead, to get credit, you must write as, say, 0 comma 3 for credit. Okay. So
Okay.
we're gonna, okay. So what we're gonna do with our equation is essentially we have to find its x-intercept and we have to find its y-intercept, and then use those 2 points in order to graph. Okay, so my equation here is the 5y minus the 7x is equal to the negative 7 times 5 plus x. Okay, so the first thing that I'm going to look for here is I'm going to look for my x-intercept. So again, in doing that means I'm going to have x comma 0 as my form. So I'm going to input a 0 for my y, and I'm going to solve for x. So this becomes 5 times my 0 minus the 7x is equal to negative 7 times the 5 plus the x. Now when we look at this, 5 times 0 is going to be 0. So we are left with just negative 7x is equal to, and then I'm going to take this negative 7 and I'm going to distribute it in. So this becomes a negative 35 and then minus the 7x. Okay. The next thing I have to do is I have to combine my two x terms across my equal sign. And notice they're the same exact term. I have a negative 7x on one side and a negative 7x on the other. So if I were to solve that down, what we would end up getting is that 0 is equal to negative 35. Now, we know that this is a false statement. What that means is that we have no x-intercept. Now, because of that, we wouldn't just simply leave it as 0. We would simply write this as none, or you could write it as does not exist. Either one of those would be complete full credit in terms of your intercept, but that is what we would identify. And it's purely because that x completely disappears out of the problem. And if you don't have an x value, you cannot have an intercept value, okay? Now, the other piece we have to find is the y-intercept, or at least to see if we have that. And so to do that, again, says that we have the point 0 comma y, which says we have to plug the value in for y, or plug the value in for x and solve. So here we're going to have the same equation, that same 5y minus 7x equals negative 7 times 5 plus x. But instead of plugging the 0 in for y like we did here, we're going to plug a 0 in for these x terms and see what happens. So this becomes 5y minus 7 times the 0 is equal to the negative 7 times 5 plus the 0. So in doing that, we know anything times 0 is itself, so I'm left with the 5y is equal to. And then again, I have to take this entire term and I have to distribute it through. So this just simply becomes negative 35 because 7 again times 0 is 0. So here, the last thing that I would do is I would divide by my 5 here to get it by itself. So we're left with a y term is equal to negative 7. Now, because I still have this y, this means that you do have a y-intercept. And when we're looking at that y-intercept, just like before, we would have to identify it. So here, this would be 0 comma negative 7. It would not be left just here as the y equals. Okay, remember, just leaving it in this form, y equals negative 7 means no credit. You have to put it into your proper form in order to receive credit for that term, okay? Now, in order to graph with your intercept points, you have to have the two intercepts. So here we would take our first and we would identify that intercept and put our little dot, on your graph. So obviously when you do this on paper, you'll use your pen and mark in your value where it goes. In Hawks, you'll be clicking into the graph itself with where it goes. And then the second part is to take your line and to graph your line. And here, my line is going to be a height of 0 and a width of, 2. Because it is going to be a horizontal line that is going to shift through on both ends of my equation. And so it would kind of look like this. Now, the reason I know it's a horizontal line is because I don't have any x-intercepts, which means this is my x-axis and I'm never going to cross it. So this is kind of that first look at what happens when you only have one intercept and not two. But that is what it is, okay? So graphing with your intercepts, this is the steps that you would follow in order to do just that, which is to graph your linear lines.
Okay.
So it's still not so bad. It's just basically plug and chug math in order to work it. So this is the same thing, graph by intercepts. What makes this one scary is the fact that we've got this fraction here. But if you remember, whenever we're dealing with the fraction, we just simply get rid of the entire fraction. So to start with, I would multiply the entire equation by 2, thus getting rid of the fraction and giving me whole numbers to work with. So my equation is going to become 2y minus 6x is equal to 9. And then once I do that, I now have to do the same thing I did before. So I can start with my x-intercept, which is the form x comma 0. So just like before, we are going to plug 0 in for y, and we're going to solve for x. So here, this would become 2 times 0 minus 6x is equal to 9. Anything times 0 is again 0, so this is the minus 6x is equal to 9. I need to get x by itself, so I divide. So this is going to be x is equal to 9 divided by the negative 6. And then when we do that, we simply reduce. So the negative pulls out in front. And then 9 and 6 both share a 3 in common, so this becomes 3/2. And so therefore we would get an intercept. That would be the coordinate point, negative 3/2, 0. Okay. Now we solve for the y-intercept. So it's 0 comma y, which says you're going to plug a 0 now in for your x and solve for its y counterpart. So here we get 2y minus 6 times that 0 is equal to 9. Anything times 0 is 0, so we get that 2y is equal to 9. And so when we solve, we divide, so we get that y is equal to 9 divided by 2, and that's not going to reduce at all, so that's how we would leave it. So this tells me my intercept point is found at the point 0 comma 9/2. So if we think about negative 3.5, that's roughly negative 1.5. And so here you would come up into your graph and you would come over -1, -2. Oh, sorry. See if that worked. There we go. So -1, 1.5 is going to be right here, kind of in the middle. And then 9.5 is the same as 4.5. And if you think about, let's say your calculator dies, there is a trick to figuring out your half locations. So when we look at, say, 9.5, if I went down by 1, that would be an 8. Well, 8 divided by 2 is even. It becomes a 4. If you went up 1, that goes to 10. 10 over 2, again, is a nice whole even number that goes to 5. 9.5 would be split between the middle, since 9 is in the middle of 8 and 10, so therefore you get 4.5. So it's just a quick trick for if your calculator, say, explodes on you, that you can still puzzle out where you go. But we graph those 2 points, and then we're simply going to connect those points with our linear line. And so you would draw your line kind of going straight through where they are, and it will look kind of something like this, give or take. And so that would be your linear line. Now, obviously, this is a computer, so my line is perfect, but I'm not asking you to use a ruler. Just as long as you're fairly close to the 2 lines you had, that's usually enough in terms of graphing. Obviously, Hawks is a computer, so it will graph the line in there perfectly, but I don't want you to worry on your test that if it's not perfect, you won't get credit. You will. Just make sure that your line is somewhat close. So for example, if your line was kind of like this more, I mean, that would still, for the most part, be okay. If your line does something more along lines of like this, I mean, obviously that's not going to work, if that makes sense. So you just want it to be as close as you can make it to the 2 points that have been given, so that I can tell that's what you were doing. Okay. So any questions on intercept graphing?
Hello.
Hello.
I'm so sorry. I think I don't know what happened, but I had to reload my whole entire laptop.
That's okay. I understand. I mean, the recording is still there, so if you missed this example here, I'm going to upload the recording into Blackboard. It'll take me about an hour to kind of get it set and uploaded, so you would be able to go back and rewatch if you needed. I was just
Okay,
simply
okay.
talking. Huh?
I said, okay, that's cool. I didn't know this was being recorded. Okay.
Yeah, I record all of my lectures always, and if there are students who show up, I then will put them in Blackboard as needed. So, yes, this will go there for anybody else who wanted to refer to it beyond the videos that are already there. So you'll be able to go back and rewatch as many times as you want.
Okay. Thank you so much.
Mm-hmm. The only other 2 examples I have are these. These are the first look at what we're going to talk about on Tuesday, which are it's like the special case kind of ideas that we have. If you look at this equation here, one of the things that you will notice is that this y is the only variable that I have. So when your equation only contains a single variable, you need to look at which variable it is. And so here, because the only variable we have is a y, this is called your horizontal case, which means the only axis the line will cross is the y-axis. Okay. And we still have to do the same thing. We still got to solve it. So here I just simply have that negative 8y equals 32. And so I would divide both sides by that negative 8. So here we're going to get that y just simply is negative 4. And this is going to give you your intercept. So here, my intercept from my y-intercept is going to be the point 0, comma, negative 4. And then it also means that my x-intercept is none because I did not have an x value. So this will just be like that other example we did, where I'm going to do the same thing and move this to the back. Oops. So my point here is going to come right here at negative 4. And then my line is simply going to be the horizontal line where I can make it straight. So it's nice. There we go. It's just going to come right in through here at -4 and expand out in both directions as far as it can. So you want to make sure you're very careful with that double arrow. The other thing that we're going to talk about next time, but I'll allude to it here, is that your horizontal case means that you have your slope is equal to 0. And it means that your B value is given. And we're going to talk about that on Tuesday in more detail when we get into linear equations using that slope-intercept form. But that is what this horizontal case is going to do. This second case here is your other. This one is your vertical case. And I know that it's the vertical case because the only variable I have is the x. So my vertical case simply means that the only axis the line will cross is the x-axis. So just like before, we have to solve this down for x. So I would divide both sides and get that x is going to be equal to 3. So in doing that, this says I have an x-intercept that's going to occur at the point 3, 0. And it also means that in terms of my y-intercept, this one is none. Our x-intercept will have a slope of undefined and no b in terms of the y-intercept value, which again, we're going to talk about in detail. So to graph this one, we're going to do the same thing. We're going to draw or graph our point right here at that intercept, but this is that vertical line. So this is going to go through and it is going to extend down in this vertical fashion, thus running parallel to my y-axis, but never actually crossing. So we're going to be more specific about these two cases when we start talking about creating equations of lines, but this is just the introduction to try and get you there. Okay. So with that, this is what ends everything you have to be able to do out of 2.3. So it's a very basic of, is this linear? So solve it down and put it in standard form. And then here's an equation and graph using your intercepts only. So do you have any questions over either of those two concepts?
No, ma'am.
Okay. Well, that's it. There's nothing else unless you have questions you want to ask. Otherwise, you're good to go.
No, ma'am, I have no questions. Thank you so much for still having class, though.
Sure, no problem. I hope you have a good weekend. And I guess if something comes up, send me an email. Otherwise, I will see you on Tuesday.
See you Tuesday. Thank you.
Mm-hmm.